Okay, so we're gonna look at this one here. We have the cubed root of xy to the 6 times z to the negative 4, okay? So we have to simplify this, and so the best way that I always think, the best way to do this is basically to split up into multiple radicals. So you have the cubed root of x times the cubed root of y to the 6 times the cubed root of z to the negative 4. Now, so the cubed root of x stays the same, so nothing happens to that one. The cubed root of y to the 6, we can do this two ways. So, basically we would have something like this. We would say, so let's see here. Okay, so we would say the cubed root of y times the cubed root of y times the cubed root of y. And then that's kind of, basically that's the first part. We can do it all the way to 6, really. So we can say another 3, the cubed root of y times the cubed root of y times the cubed root of y. Now, we know that to cancel the cubed root, we have to multiply y 3 times. So this gives us the cubed root of y cubed. These two cancel out, this just gives us y, and we still have the cubed root of x over here. This also gives us y, so we have y. Basically, we have y, and then this also gives us y because we have the cubed root of y cubed, and to get rid of the cube root, we just multiply y 3 times, so we get y. Now, it's not going to be y cubes because you're saying the cubed root of y cubed. That means that these two cancel out, so the radical also cancels out, and you're left with y. So your answer for this one, and also the z to the negative 4. The z to the negative 4, the cubed root of z to the negative 4, that's another one. So the thing about that one is that you're going to have the cubed root of 1 divided by z to the 4 to the 4th. And the thing with that one is that basically, so we have the cubed root of 1 over the cubed root of z to the 4th. Now, the cubed root of z to the 4th, since the number in the radical is bigger than the number outside, or the number in the of the root of the nth root, we can split this up, really. So we have 1 divided by, and then we say the cubed root of z times z times z times z, and we know that, again, we know that to get rid of our root, or our radical, we have to do the cubed root of z cubed and then times the cubed root of z, because when you multiply these two, you get the cubed root of z to the 4th. And then once you do that, you just go ahead and cancel these two out, and you are left with 1 over z cubed root of z. And so, basically, with what we already have here, we have the cubed root of x times y squared, and then we have times 1 over z cubed root of z. So our answer ends up being the cubed root of x times y squared over z cubed root of z. Or we can also say that's equal to the that's equal to y squared cubed root of x over z cubed root of z. Now you can go ahead and get rid of the radical if you want. So give me 1 second. Okay, so you can get rid of the radical if you want. So to do that, what you're gonna do, so some teachers will let you just put it like this, but others are not that, they're not that nice. So basically they want to get rid of the radical on the bottom. What you're gonna do is you're gonna go ahead and multiply. So we need to get rid of this radical, we need 2 more radicals of cubed root of z. So what I mean by that is that we need to multiply by the cubed root of z twice. Okay, that'll get rid of the cubed root of z on the bottom. So that will leave us with y squared cubed root of x times the cubed root of z squared divided by z, and then times the cubed root of z cubed. So basically we're going to have something like this: y squared times the cubed root of x, and then notice that they're both cubed roots, so we're going to bring them together. Xz squared divided by z, and then the cubed root of z cubed is just z, so z times z, and we're gonna end up with y squared times the cubed root of x z squared divided by z squared. And this, ladies and gentlemen, is our final answer.